Hello and welcome. Today we're going to be working through a practice page called Dihybrid Practice Problems. We are going to work through each of the steps and show the phenotypic and genotypic ratios and answer the questions. So looking at number 1, it says, in man, assume that spotted skin, capital S, is dominant over non-spotted skin, lowercase s, and that woolly hair, W, is dominant over non-woolly hair, little w. Cross a marriage between a heterozygous spotted non-woolly man with a heterozygous woolly-haired non-spotted woman. Wow, so many words. We're going to work through this just one step at a time. The first thing we need to do is write down our traits. And so the first trait that I'm going to write down is skin spots. And I don't know if that means freckles or if that means larger spots, but we're going to look at skin spots, and we're going to assume that spotted skin is dominant, meaning that we will label it with a capital letter S, and the S comes from the dominant trait, is dominant over non-spotted, which will be a lowercase s. All right, so that is trait number 1. Trait number 2, the second trait is, I'm going to say hair texture. And it is woolly hair, which is the dominant trait. So we'll go ahead and name that, over non-woolly, which is a lowercase w. All right, and so we're going to so that now we have our genes written down. We have each gene written, and we have the alleles or the gene choices written, along with the dominant and recessive trait information. All right, so the next step is going to be to write the parent phenotypes. It says cross a marriage between a heterozygous spotted, okay, heterozygous means different, so we'll have a heterozygous spotted non-woolly man. Now, in order to be non-woolly, it's going to have to be homozygous recessive. Okay, heterozygous spotted non-woolly man with a non-spotted, let's see, we'll get the pink, non-spotted, which is little s, with a heterozygous woolly-haired non-spotted woman. Okay, so she's heterozygous for hair, which means big W, little w. Okay, we want to keep the letters in the same order, and we want to group them together. And if we have a capital, we always want to put that one first. The next step is to determine the possible gametes of the parents from their genotype. So the genotype, of course, has all the information for each trait. The gamete says what could be passed on to the next generation, and we will look at the FOIL method, first, outside, inside, last. Okay, so our first, we've got capital S, lowercase w, outside, again, capital S, lowercase w. Inside, little s, little w. And last, which is little s, little w. All right, and that will go with our first, outside, inside, last, which is little s, capital W, little s, little w, little s, capital W, and little s, little w. All right, and now our next step will be to fill in the traits, to fill in the dihybrid cross. So I have my dihybrid cross box, the Punnett square, and we're going to fill that in. So take my s from here, my s from here, my capital W from there, and my lowercase w from there. All right, take a moment and fill in the rest of the Punnett square. All right, I have completed filling in the Punnett square. If you'd like to take a moment, pause the video and check to be sure that yours matches with mine, that's fine. And now it says to give genotypic and phenotypic ratios of the offspring. And so what I'm going to do is I'm going to write down each of those, and I'm going to make a count. So let's see, so I'm going to make a little bit more space right here. And I may even see if I can move that over there out of the way just a little bit and give us some space to work here. All right, so let's see. Let's choose a color that we haven't used yet. So I'm just going to write this one: capital S, lowercase s, capital W, lowercase w. Heterozygous for both traits. I have 1, 2, 3, 4, and then all these are homozygous recessive for the skin spots. Okay, so I had 4 of those. All right, let's just move to my next one. Capital S, lowercase s, and then 2 lowercase w's, homozygous recessive for that. Let's count those, and I'll mark them with an X. 1, 2, 3, 4, and then again, those are all homozygous recessive for spots. So again, we have 4. I'm sensing a possible pattern here. Let's see. Non-spotted, heterozygous for woolly hair. 1, 2, 3, 4. And now homozygous recessive for both. 1, 2, 3, 4. Okay, and so once again 4, and so I only have 4 genotypes, 1, 2, 3, 4, and each of them has 4 possible offspring that might meet that. So 25% each for that. Then I would look at what now let's see, that would be a spotted woolly phenotype. Four of those. A spotted non-woolly, a non-spotted woolly, and a non-spotted non-woolly, again with 4 of each. And so we would write those down and include that data as well. All right, so that is how we do that. Let's do one more. All right, so I'm going to skip number 2, and I'm going to try number 3. So where it talks about squash. So we'll be talking about number 3 with the squash. So our first step will be to write down the traits that are present. And so it says white fruit color is dominant over yellow fruit color. So I'm going to write down the trait of fruit color. White is dominant over yellow. Now that means that we will represent the white fruit with a capital W, and the yellow fruit with a lowercase w. All right, that is one of the traits. It says, and disc-shaped fruit is dominant over sphere-shaped fruit. So we had fruit color, and now we're going to have fruit shape. Disc shape, and let's see, it's spelled with a K, all right. Disc shape, capital D, sphere shape with a little d. Okay, and so those are our traits, and we would need to write that down. If a squash plant true breeding for white, okay, the term true breeding is code for homozygous for that trait. So something that is true breeding for white. So we will say homozygous white, and also true breeding for disc-shaped fruit. So true breeding for white disc-shaped fruit is crossed with a plant true breeding for yellow sphere-shaped, for yellow, which means lowercase, and sphere, which means little d, fruit. All right, and we're going to cross those two. So our next step is to do our FOIL first, outside, inside, last, and I can quickly see that it's going to be all capital W, capital D. And then again, first, outside, inside, last, and I can see it's all going to be lowercase w, lowercase d. All right, filling in, bringing a capital and a lowercase and a capital and a lowercase. All right, and then I'll ask you to continue to fill in the remainder. Pause the video and do that. And since we had all homozygous dominant and all homozygous recessive gametes, we're going to get heterozygous for literally all of our possible offspring. So that is going to be 100% or 16 out of 16 heterozygous for both. For both traits. And it will also be 100% white disc-shaped fruit. All right, thanks very much. I hope that was helpful for you. If you get lost on working any of the others, just go back and watch how we worked these first two samples and do the same thing with your new problem. I hope that was helpful, and have a great day.